for a while, and then they will lay down and chew their fat. It's actually the term is.
And welcome back to the next installment of my electrical calculation playlist. This video will have two goals. One, to teach you how to perform a percent fill calculation for conduit in accordance with NFPA 70, National Electrical Code, and also to calculate the minimum NEC compliant conduit diameter. The video will be broken down into several sections. First, we'll go over the nomenclature that will be used throughout this video. We'll go through the formulas as well as the code requirements that are needed to perform the calculations. And finally, we will do several examples. You can refer to the description below for the table of contents. The nomenclature for this video is very basic. We have area in units of square inches, diameter in inches, radius in inches, and subscripts are so basic they're self-explanatory. There will be four main formulas that we'll be using for this video. The first group is the elementary school formulas, the formula for area, which is area equals pi r squared, r being your radius, and just a reminder, your radius is equal to half of your diameter. The next formula is the percent fill of a conduit. It's basically a ratio. It's the area of your conductor divided by the area of the inner conduit times 100 in order to get a percent. If you're trying to do a down and dirty calculation, you can use the outside diameter or the trade size of the conduit diameter of your calculation, but we're going to try to do this as exact as possible, and why we want to do it this way will become clear later on in the video. Now let's break this formula down a little further. How do you calculate the area of your conductor? Well, let's move on to the next formula on the bottom left-hand corner of the screen. To calculate your area of the conductor, it's the sum of the area of your conductors, where pi times the radius squared of your conductor times the number of conductors equals your area. Now here's an interesting little tidbit from the National Electrical Code. The NEC will allow you to treat a cable as one conductor. So just keep that in the back of your mind, and this concept will become more clear later on in the video. Now before we move on to the last formula, I'd like to demonstrate that the percent fill of a conduit formula can be simplified up front. So if you look all the way at the bottom, I show how to simplify the percent fill formula. So effectively, if you kind of break down the area of the conductor formula and add that portion into the percent fill formula, you can cancel out the pi's, you can cancel out the 2's in there, and basically you're just left with the diameter of the inner conduit squared times the number of conductors divided by the diameter of the inner conduit squared. We will demonstrate using this formula on the first example, but moving forward we're going to do everything the long way, because why wouldn't we want to make extra work for ourselves? Lastly, we can use all of these formulas to determine how to calculate the minimum conduit diameter. The way you do this is you take the square root of the area of the conductors and divide that by pi times the allowable fill per the NEC. That portion of the formula will effectively calculate the radius, so you multiply that by 2, and that's how you determine your diameter of the inner conduit. All of the rules pertaining to conduit fill are located in Chapter 9 of the NEC. If you're having trouble sleeping, you can read through that chapter. Otherwise, I have summarized the 4 main points from that section. Rule number 1 is that you're allowed 53% fill when you have one conductor inside of conduit. But keep in mind, as mentioned a moment ago, this also applies to multi-conductor cables. So when you have one multi-conductor cable inside of a conduit, again, you're allowed 53% fill. The second rule applies to 2 conductors or 2 multi-conductor cables, you're allowed 31% fill. Rule number 3, when you have 3 conductors or more, or 3 multi-conductor cables or more, you're allowed 40% fill. So now that we have a few formulas in our toolbox, and we also know what the code permits us to do, let's do a couple examples. Let's pretend that we're going to review some drawings that were submitted to us. We have 4 examples here, each with a different scenario. We're going to make a couple assumptions. One, we're going to assume that all conduit being specified is rigid galvanized steel. 2, we're going to assume that single conductors are stranded copper type USE2. And lastly, we're going to assume that multi-conductor cable is stranded copper type XHHW2. I have copied and pasted the data sheets that pertain specifically to the assumptions, and we'll use these for each of the examples that we do here. Alright, so example 1. We have 3 single conductor number 12 wires, 1 single conductor number 12 ground in 1-inch conduit, or basically we have 4 single conductor number 12 wires in 1-inch conduit. Step 1 of determining what the percent fill of the conduit is to calculate the area of the conductor, or conductors in this case. So what we will do is refer to the data sheet, number 12 wire has a outer diameter of 179 mils, or 0.179 inches. So you plug that into the formula as shown, and be sure to multiply the area of the conductor times 4 because you have 4 single conductors. And from that, you calculate what the area is. It's 0.10060874 square inches. Now step 2 is to calculate the percent fill. We're going to take the area that we just calculated and pop that into the percent fill formula. And we will divide the area of the conductors by the inside diameter of the conduit. So referring to our data sheet, the inside diameter of the rigid galvanized conduit is 1.049. Plug that into the formula as shown, and we determine that the fill percentage is 11.6%. Now, what did we say before for our NEC requirements? We're allowed 40% fill. 11.6% is well below the limits, so this is acceptable. Now, if you recall, we had determined a simplified version of the percent fill formula. So we're basically able to calculate the percent fill in one step. As you can see, all you need is the diameter of the conductor, the quantity of the conductors, and the inner diameter of the conduit. And with those items, you come to the same conclusion. Alright, so let's take a look at example number 2. In this scenario here, we have 1 4-conductor number 12 cable in 1-inch conduit. So similar to the last example, the first step will be to calculate the area of the conductor, or really the cable in this case, and plug in 0.406 inches into the formula. We get 0.1293926 square inches. And then step 2, we're going to take that calculated area and plug that into the percent fill formula. Again, just like we did in the last example. Again, we have 1-inch conduit, and once we plug everything in and calculate it, we come out with 15% fill. The National Electrical Code tells us that we're allowed 53% fill for 1 conductor or cable. So again, in this case, we are well below the limit. This is acceptable. Alright, example number 3, we start to get a little interesting. We have 3 single conductor number 4 wires and 1 single conductor number 8 ground in 1-inch conduit. So for step 1, if we refer to our data sheet, we have 2 different types of conductors here, 2 different outer diameters. So when we do our calculation, we have to add together the 2 areas. And when we do that, we get 0.33296246 square inches. Step 2 works the same way as the prior two examples. We're going to take that area of the conductor, plug that into our percent fill formula. Again, we have 1-inch conduit, and once you have everything plugged in and calculated, you come out with 38.5% fill. NEC tells us we're allowed 40% when we have 4 conductors in a single conduit. Again, we are below the limit specified in the NEC. Again, this is completely acceptable. In our final example for percent fill calculations, we have two 3-conductor number 4 wires with a number 8 ground in 1-inch conduit. So I realize this reads a little funny. So just to clarify, this cable consists of 3 number 4 wires as well as a number 8 wire, which serves as your ground. So effectively you have 4 conductors inside of this cable, and there's a quantity of 2 of those. So step 1, as with the prior examples, we're first going to calculate the area of the cables, and we come out with 1.01487312 square inches. And once again, we plug this into the percent fill formula and account for 1-inch conduit, and we are way above the allowable 31% that's allowed by the NEC. So this is completely not acceptable. This would have to be recalculated by whoever did the design, and we'll actually revisit this a little later in this video. So now that we've done a couple examples for percent fill, let's use some examples of determining the minimum conduit diameter. And we'll use the same 4 examples. We'll try to optimize what was originally designed, or in the example of number 4, we'll try to correct that and determine what is an acceptable conduit to be used. We're going to make the same 3 assumptions as with the previous examples, as well as use the same data sheets for conductors, cable, and conduit. So example 1 again, we have our 3 single conductor number 12 wires, we have 1 single conductor number 12 ground, and 1-inch conduit. Again, we have 4 conductors. First step, you guessed it, you have to determine what the area of your conductors are. Once you've made that determination, step 2, you're going to use the formula for minimum inner diameter of the conduit. So you're going to plug in the area of the conductors that we determined in step 1. We're also going to plug in the allowable fill as permitted by the National Electrical Code. In this case, we're allowed 40% fill. So once you plug that number in, you can calculate that the minimum allowable inner diameter for the conduit can be 0.57 inches. Now this is where it gets fun. We just calculated a little over half an inch. Making an assessment based on the trade size, we would think that, oh, we can't use half an inch conduit, we have to bump up to the next size, 3/4 inch. However, that's not exactly correct. Let's take a look at our data sheet here. Referring to the data sheet, for a half-inch conduit, the inner diameter is measured at 0.622 inches. Considering that, it is completely acceptable to put your conductors inside of half-inch conduit, assuming that your contractor is in fact installing this specific conduit. If not, obviously you'd have to reevaluate. Let's take a look at example 2. Again, we have 1 4-conductor number 12 in 1-inch conduit. We're going to start with calculating our area of the cable, and then step 2, we're going to plug that area inner conduit diameter formula, and we're also going to plug in 53% for our allowable fill as per the NEC. Once we calculate that, we come out with a inner conduit diameter of 0.56 inches. And same as before, in accordance with our data sheet, half-inch trade conduit has an inner diameter of 0.622 inches. Again, it would be completely acceptable to use half-inch conduit for this cable. Example 3, we have, again, 3 single conductor number 4 wires and 1 single conductor number 8 ground and 1-inch conduit. Again, we're calculating our area and actually adding the two areas together, the area for the number 4 wire and the area for the number 8 wire. And then we're taking that area, plugging that into the inner conduit diameter formula. This case, we're using a 40% fill percentage. And when we calculate the inner conduit diameter, we come to 1.03 inches. So same as the last two examples, if you're basing this purely on the trade size of the conduit, 1 inch is not going to cut it. However, again, if you look at the data sheet for the conduit, 1-inch conduit has an inner diameter of 1.049 inches. Well, in that case, we just squeaked by. We can use 1-inch conduit for these conductors. And in our final example, if you recall, we were way off in our previous fill calculation, and 1 inch was not an acceptable conduit size for these two cables. So again, step 1, we're going to calculate our area. Step 2, we're going to plug that area into the inner conduit diameter formula. For this case, we're allowed a 31% fill, and when you calculate that out, you come to 2.04 inches. Referring to the data sheet, 2-inch conduit has an inner diameter of 2.067 inches, so 2-inch conduit, perfectly acceptable. Thank you so much for watching. Please check out my other videos.